Thanks, Alex. Yeah, great, great. Thank you, Uli. I've been asking you for 8 years to let me come speak at an event since a former life when I used to do it more. So thanks a lot. Thanks, Oliver. I had to mention it. Yeah, we are etcetera. As Alex said, we founded etcetera a few years ago with my wife, creative partner, and steady hand on the till. So to say, we are both a design consultancy and a studio. We have research projects and clients for which we do design consulting. And then on the other side, a kind of more entrepreneurial side of things that we do, which is more of what I'll talk about today, at least on the 3D printing projects that we are involved with. Yeah, and since the beginning, we've had an idea about radical innovation. So we want to push the limit, but we understand that there must be an incremental approach to that. So it's sort of cheeky for you guys title, take it one layer at a time. Take it one step at a time with kind of big visions at the end. So we start really big, and this is where we sort of straddled the studio design consultancy area. We were approached by the guys from Caracal, many of you know them, to present ideas about remote 3D printing. This idea was to take a support vessel, so this is a commonly used boat for servicing oil rigs, now often used for super yachts, in fact. And our idea was, okay, you guys need to remote 3D print. They had a use case already. Let's turn a boat into a 3D printing factory so that it can service windmills, for instance. This was, for them, a bit of a marketing pitch to think about remote 3D printing, something that they were actively becoming involved in. This is a different kind of remote 3D printing, part of our Winova project, which really got us started, or I should say restarted, into 3D printing. You're thinking about how far can you go out to the Antarctic, what might that involve, and how to trigger, particularly people like you, what we're trying to do. But there was a little bit more pragmatic approach within that project, somewhat more pragmatic, where we at least had a kind of typical use case, thinking about renovation of facades. We know this is a large market, up and coming in Europe, and how might that be done in the future? But by pragmatic, I mean, we stepped back a moment at least and thought about, okay, there are certain layers to a facade. You've got interior, exterior, you've got structure, you need waterproofing, you have insulation, and we broke that down in an abstract way with a little bit of computation, which you'll see in a moment, and understanding what might that be, as you kind of saw in the last presentation, what could that be in the future. So with our friends from Differential, you always see we add our partners into the slides as often as we can. We think this is super important. I just add that as an aside. We don't do this by ourselves. In this case, the computation for Winova was about determining the amount of structure or thermal insulation that we would need. Of course, you get the obligatory grasshopper screenshot to go with that. But to understand what we might need for a building. And then we took that even deeper. So we thought, because, is that working, that one? Yeah. We thought our background, my particular background is in facades, where I know Uli from a former life. And we thought, what could that detail be? We're looking here at our idea of thermal separation while maintaining structural continuity within this wall system. But we weren't totally crazy. You know, we had some help from our friends at Eggers O'Callaghan, rather well respected, and they took us seriously, unbelievably, to think about what we might need, for instance, in this case, to get below a 0.25 U value. What would that take? In this case, we're also using PA6 as the conceptual material. So not only is it a big vision, but we're saying, okay, how might we get there, and taking it as seriously as we could. The other side of the work that they helped us on was to look at the embodied carbon. And part of the project, and part of the process of the project, and the goal of the project was to understand that this could be constructed or printed, demolished, shredded, and reprinted on site. Of course, your initial build, in that case, the carbon footprint, well, is not as high as your typical facade, but lower than timber. But the idea being, if we can recycle, then that goes down precipitously. This, after 2 rounds of recycling, that carbon footprint goes down. And that was another piece of the kind of proving grounds of this project. So luckily enough, also here a couple of years ago, when the first time I met some of you, Caracol printed a test. This in this case was a concept for an interior wall, but they printed it and it was displayed here at Beam. But already you see, back from what we had in Rhino, thinking about how to structure this. In this case, it was about acoustics and the structure of the wall, but how we use the form, the toolpath, the design, or as a design, in order to inform the prototype. We take that, again, to the next scale. Very interesting to see the guys from SSV to do this at an even bigger scale, with somewhat less complexity, perhaps. But this idea of grow was combining the idea of 3D printing with the idea of progressive housing. So, back to phase 1. So you might lay down the tracks, you have the gantry come in, you print the first phase of a house, someone can live there. Second phase, when they have enough money, perhaps, when the time is right, they print it in the third phase. Again, you see there's some ideas here of having prefabricated roofs and such. This will come back in a later project as well. So the specifics of progressive housing, as some of you might know, is common in South America, for instance, is about allowing people to grow. And our idea is using the idea of 3D printing in order to improve people's lives. So just like this, as we say, right, there's a young family, then the family grows, and grandma moves in, and you have the possibility of growing. And of course, within that, you could go from your smallest house, so 350 square feet, $86,000, up to maybe 2,000 square feet and $520,000 over time, with assistance, and as we imagine it, with assistance from the neighbors in your neighborhood. This project was about also creating that community around progressive housing. There are companies and organizations such as Habitat for Humanity in America, where the project was based, and where people are helping each other. So we think about upskilling, we think about sharing, shared spaces, and use of community spaces. And of course, important with that is to bring in as much kind of responsibility for the community and for the environment as we can, whether that's rain collection, adding greenery, creating small amounts of wind energy, and lots of green areas to be shared by the community. And we think this is, and I'm really excited to see from the guys from SSV, that this could be a possibility, and the possibility of using a new technology to create a positive societal effect. Let's say at the opposite end of the financial and architectural spectrum from progressive housing, this is a project with an undisclosed client around the Mediterranean for a remotely located house in a harsh environment, where we thought, and the client was interested in pushing the future and the technology of the possibility of their house, and we thought, well, it's a good instance to think about 3D printing. Think about 3D printing with on-site materials, for instance. So the big idea of the project, from the kind of what would be the realization to the process, is to extract some soil, rocks, gravel, etc., from what is the side of the mountain, and use that for the production of the house. Luckily enough, there was some usable materials for the concept. But for us, what was really interesting in this, is then using the process. So as you might well see, we borrowed, with their permission, some of the concepts from WASP, so the SCAR printer, get a little bit of consultancy from them to understand what might be possible. And so what was important for us is using the organization of the production process, construction production process, in the organization of the house itself, and of course the end aesthetic, where you see, for instance, the courtyards are created where the robot arms are, and then the way the roof is divided is about being able to prefabricate it. So it's, and as I'll repeat again, it is a house first, right? It's not just a 3D printed house, but it's a house. And I think this is part of where the industry is now and should be. So there's, in the front, there are common areas for families and guests. In the middle, the living area, and towards the back, the private areas for the family. And so it's important that spaces like this, which is where one of the small arm printers would have been, but is now the entrance and the kind of main distribution area for people going to their guest bedrooms, is important that this has a wonderful effect and a beautiful appearance for the users. Then in the middle, of course, the whole house is centered around a central exterior courtyard, and the kitchen, living room, a pool, the back patio, etc. Once again, remembering exactly how it was built and using that for the effect of the living space. And it sits then kind of gently, simply on the edge of the mountain. And once again, what's important with this, it's not just a one-step process, but the obligatory environmental systems diagram, where we use some traditional ideas about how to bring fresh air through the house in these same courtyards, and then some of the other very specific ideas that we developed for different parts of the house. So for instance, in the small courtyards, you have the small wind lenses. The automated screens are also meant to catch some humidity in this sort of desert and oceanside climate. The roof is with xeriscape, so this kind of desertscape, which would also collect water when it rains, because when it rains, it pours. And of course, the large wind lens in the middle is the main ventilation and light providing area of the house. Yeah, and of course, this here is looking from one of the small courtyards through the middle, through the other, and this is really kind of what the house is about. So just to show exactly how we thought this through, the whole idea is that we have, for instance, as I mentioned, there's sort of a large arm printer, another one on the left, you get a small arm printer creating the courtyards. The organization, then you have material storage, granulator. Of course, as was just shown to us, there's a limited amount of labor that's needed for this. So there's just a control center, charging station, where the idea was that robots are basically using the barrels that are inside of each of the arms, which contain a polymer activator, which is then mixed on-site with the materials that are in the storage containers. And of course, as I mentioned before, there's this pre-printing zone where you see how the roof panels could be printed on the side. And these are all things which, we spoke with WASP about this before and after, and these are all things which are possible in the moment, or potential in the moment, possible in the near future. And we use these ideas to sort of push that along. Luckily, we've begun to realize things as well. So the most recently, and what you can see at Beam and also on the Smart Materials and Nagami stand is the Septa chair, where we've begun to kind of lay maybe that first layer or the next layer in our process of bringing 3D printing into design. In this case, once again with our friends from Differential, we sliced the chair in a way that's very important, given the complexity of the form. We sliced it in so that there's an alternating set of lines, or of paths, I should say. Right. So when you see the chair, I encourage you to check it out at the Beam stand, and there's a different one also at the Smart Materials stand. Sit in it, feel it, and for us what's really interesting with this path, so we'll start over. So it's an AB-AB combination. Let's see. Yeah, so when it starts over here at the end, you will see in the blue, it will double back. Yeah, so it doubles back. And each at the top and on the bottom and the back, it needs to switch back and forth. And this, for us, of course, was a necessary solution to solve the kind of 3-layer problem. Otherwise, you need an even number of layers in order to make a continuous loop. So that solved that problem. But then it gives us something much nicer, which turns a 3D printed chair into a chair that's 3D printed, meaning that we then really can focus on the details. We focus on the way that each surface hits the other. We focus on the way that the structure hits the surface below. And we focus also in a very, very strong way with the guys from Nagami, who really can pull this off in an unbelievable way on these seams. And for us, this is like the most important detail of the chair, or the real detail of the chair, what you won't see anywhere else, besides just the quality, but to say, okay, this is now what we feel is something different. We're taking this a little bit to the next step. So that this, first of all, is a chair. It's comfortable. Like I said, I encourage you to go sit on it. It's lovely. I say that as objectively as possible. But we are now being able to take some of the ideas that we've had and push them forward. And we hope that this is now one small layer for us, for everyone else, and moving towards the more, a wider spread, more democratic use of 3D printing. Thanks. Oh, you're not on.
Okay, now officially. Thank you, Rob.
Yeah, was it time? No.
There was a raised hand. Or was it a stretch? Oh, it was a stretch. Yes.
No cracks.
Any questions from the audience? Obviously not. To be honest.
Where's the house? The second one. Undisclosed location. Unfortunately, I'm not allowed to say. But let's say a desert environment along the ocean. That's all I can say. Sorry. It takes yeah.
So, Adi?
No. Thank you.
Thank you for the talk and the presentation. My observation at Formnext is that it's really my personal observation that we were promised to get custom-made shoes, glasses, everything. They will scan our bodies and then custom-made the things that we need to wear. What I see at Formnext is a lot of serial production. AM 3D printing is used for serial production. Did you ever have plans to kind of customize furniture? Is that something that would be of interest for you, or do you have an explanation why things are more serial than we expected them to become?
Yeah, I mean, you have to ask Manuel when he gets in here why it's not possible. But yeah, of course, and everybody asks. And the thing is, so we were at a fair a couple of weeks ago, and everybody, because everybody's aware of 3D printing, this is not so new anymore for even the folks on the street. They ask, oh, you can customize it, you can do anything you want. Can I have it bigger? Can I have some armrests? Can I have a headrest? And at the end of the day, there's still difficulty in that, right? Like, it is possible, and for sure we have these, for the chair, for instance, it is possible, and it's easier. It is easier, but in the moment, like moment to moment, and the idea for the chair particularly is that it is meant to be sold. Like, this is a real objective, yeah? It's not a joke. It's not that it's meant to be only a museum piece, oh, that would be lovely. It's meant for you to sit in it. And that means that it needs to still take a certain path. And I think you can hear it a little bit from others. While we work over here, and that's also kind of my point, while we work and think over here, in order to get things going, you need to get in the path of the known existence, right? It's got to go to a distributor, and to maybe even to a retailer, and then you got price points, and you got materials, and you got tests, whatever, right? And I think that's still a reality, but we see it. I mean, totally in the definition, the slicing definition that we put together, with differential, of course. That's possible. Like, we could rebuild the surfaces each time. The next step is then just a little bit more difficult. But yeah, I think we see it. It's the first time we can say, okay, that's possible. okay, let's get it done, and then we kind of move to the next piece. But I think, yeah, we're gonna do another piece probably with them, and then we'll test it, right? So how easy is it? How easy is it to replicate that process, right? This specific kind of process. But yeah, I get it, and also everybody wants a different color, and yeah, it's possible, but there's still a reality in it, you know. I think and I'm sure the guys that are printing bigger things have even tougher stories, you know. It's like it's been 5 years, I think, as if I see the timelines on those. So it still takes time. But yeah, we would, of course, that would be amazing. But you need a market for it. This is also the thing, yeah. One layer at a time. Yeah, exactly. But we keep our eyes on the future, you know. Yep.
Thank you for the nice presentation. I assume the inner infill layer would kind of give you the ability to control the flexibility of the chair, kind of. Is this something also that has been analyzed, like for example in finite element analysis or something like that beforehand, or just tested by iteration and printing?
There was only testing afterwards. So in that sense, it's more like typical furniture. We understand the basic shapes, the ergonomics, the basic shapes. Nagami, as producer, understands the material and the process. And then there was some back and forth on optimization and some testing of materials. But it's more like typical furniture. We don't do a finite element analysis normally on a chair. And so we wouldn't do it here either. I think it's also, getting beyond that is also important, right? It's not, we don't need to do it. So it's not always necessary. And I think this is a good realization, it's a good step for us. But fair enough, we not to say that we didn't think about it and we didn't want to do it and we wouldn't think it was cool to do the diagrams, but it's not necessary.